Hey everyone, so welcome to this complete Python fast track course. Um, so if you are starting a journey into programming or planning to get into AI, backend development, automation, or data science, Python is one of the best languages to begin with. So Python was created by Guido van Rossum in 1991. His goal was very simple. There are a lot of problems to solve in today's world. So he wanted to create a programming language that is very easier to understand and yet powerful enough so that people can solve and build real world systems. So in current era, Python is actually used in AI, web dev, automation, backend systems everywhere. We can't name a field without Python now. So uh, Python makes the problems very easier to solve due to its simpler syntax and efficiency. And before we jump into the coding, syntax of Python, etc., and relevant data structures, we need to understand something very important. So we need to know how Python actually runs. So any code we write it as a high level language that actually should get converted to machine language, which is basically zeros and ones, binary language. This is done by using a translator. So for example, if we write print hello world, we can understand this easily that you're trying to print hello world on the screen. But how a computer will understand? It can't understand directly. So computer understands only zeros and one. So this is where something called a translator comes in. So translator basically converts the high level language into low level machine code. There are two types of translators we can see. There is compiler and there is interpreter. So Python is actually an interpreter based language. Compiler is basically used by C++, Java, etc. So we need to know the difference between compiler and interpreter first to understand the basics of programming. So compiler translates every program at once, and then it creates one .exe executable file. So once that file is created, you don't need the source code to run the file again. Just by using the .exe file, you can run your code and then do stuff. So by this way, compiler is very fast. The execution of compiler is very fast, and the languages which use compiler are very fast. C, C++, Java. If you know, they are heavily used in the backend of financial systems, etc. Because it's very fast. And whereas coming to the interpreter-based languages, so a interpreter actually executes the code line by line, and there is no separate executable which is created like .exe or anything. It is very slower, but it is very easy to debug because it will exactly point out the line where the error is and then stop the program flow. So you can just rectify it and then move to the next. Basically, Python uses interpreter language, JavaScript, etc. All those uses interpreter based language, but in general, interpreter based languages are kind of slow. Yeah, so this is the major difference which we need to know. We need to understand this difference very properly. Yeah, and since Python uses interpreter, debugging in Python is actually easier. It actually tells you where the error happened. So yeah, basically this. And let's start coding. Okay, so I'll just show you how an interpreter actually works. So if I just type here, okay, so here I give a wrong statement. Basically, like you say 10 divided by 0. This is actually not possible, and this should uh, not be executed. Okay. So if I just run this, it will give the trace back as division by 0 and then stops the program. Python executes the code line by line. So the moment it finds the error, it just stops it. So this is basically how the interpreter behaves. So you can just debug this error line. Okay, you can divide by 0. So you use anything above 0, which is 2, basically, and then just write it. Now yeah, see, it gets executed. So this is way the interpreter behaves, and then it's very um, better, easier to debug using Python. Secondly, we need to know why Python is powerful. So Python has a very clean syntax. It has a very large community. The massive stable libraries for AML, data science, everything is in Python, like TensorFlow, etc. So, and very majorly used in AI and backend nowadays. The fast API, all are Python frameworks and is very heavily used. So, you might ask why Python is dominating today. Uh, Python has NumPy for numerical computing, Pandas for data analysis, TensorFlow and PyTorch for AI, Flask and Fast API for backend. Basically, Python allows you to write less code but do more efficient work. It is very beginner friendly and yet you can be industry ready as well. If any company uses, it's focusing on Gen AI, agentic AI, then by learning Python is very important. So let's I guess we understood this section. So let's move to the next section. So now that we understand how Python runs and works, how it is working on interpreter, etc., let's talk about something fundamental: variables. In simpler words, we can say that variables is a container that stores data. We can think it of like a labeled box. So the label is the variable name, and the value inside the box is the data. I can just create two variables and show you. So name equal to maybe Python, and the um, age equal to 21, and any other variable like you know month equal to Feb. So all these are variables: the name, age, month. All these are variables which stores the respective data, and each of these variable have their unique IDs. So if you want to see the ID of a name, yeah, you can just see it. So if I just run it, I'll get the idea of name as this. So similarly, if I want to get the idea of age, so all these are different. So this shows that each variable is stored in a specific container, a specific address by which it can fetch the relevant value and just give us. So there are few things regarding this IDs address that we will later get to know regarding immutability and immutability, that we will see it in some time. So second thing which I want to tell is that Python is dynamically typed, which means that in some programming languages you must specify the type of variable. For example, in C, for writing the same for declaring the same age variable, say you have to write it like int age equal to 21. So this is not needed here. Python, this is Python. So Python is dynamically typed, which means that during runtime itself, Python will get to know the nature of the variable age. So it will like, no, okay, no, bro, it's like int. So you can directly, I can classify it as int. Why are you specifying it? So Python will like, okay, bro, in runtime I'll do everything. You do no need to worry. Python automatically understands that 21, the value which is stored is an integer. This is dynamically typing. And second thing is type checking. Python in Python you can like type check like this. So if I specify this x equal to 10, I'm going to type check this. You can just check it like type of x. So it will return what type of variable it is. Yeah, so it will give the type as integer. So you can just refer to it. And I'll show one more thing here. So I first initialize x as 10. Now I'm supposed to say initializing x as Python. This is a string. So what must be the type of x now? So type of x now is string. Same variable name, but the type is different. Python allowed it. So this like shows that Python checks the types during execution and not before. So this is a very important thing to know. Python checks the variable types during execution. It doesn't check before itself. So this proves that it is dynamically typed. Secondly, we need to know how memory works. So that is very crucial here. So if I say like if I say x equal to 10, and then x also points to something like hello. X equal to 10 is an integer, and x equal to hello is a string. So what actually happens internally is that when we assign x equal to 10, Python creates an object in memory of 10. Then x points to that object. So later when I reassign the variable x, which was initialized as 10, to hello, Python creates a new string object. Now x points to that object. So the old object, remains in memory until the garbage collections remove it. This flexibility actually makes Python very powerful and easier to use. So I'll just show you the difference. So first I initialize x here. So I'll just show the ID of x. Okay. So print ID of x. Now after initializing it to a string, now I'll print the ID of x. You can see the difference. So how it is being stored. you know you can see the difference in the memory address stored here. So initially when it was a string, it is stored in a different location, and when it was integer, it is stored in a different location, and when it is a string, it is stored in a different location. So this is a very powerful feature in Python. Now let's come to the next section of getting input from the user. So very simple. To get input from the user, we just need to define a variable x, maybe say x equal to input of, enter a name. So by this way we can make the user enter the input, and in we ask for data in many cases, so we need to know it. Secondly, the input function now which we give here, always it has a return type of string. So what we need for a few things which we need, like integer, we need to do typecasting on it. So we can just write it as in the input, we can write it at x equal to int of input, enter age. So Python allows typecasting, and then you can just convert the string to integer to string, etc. So you can just dynamically typecast things. This is one of the common feature in Python. The second thing is that um, you can also assign multiple variables. A variable assignment. So basically, you can may also do it like a comma b equal to 10 comma 12. So this is one more way by which you can assign variables. So here a will be assigned to 10, b will be assigned to 12. So this is actually very dynamic feature in Python for assigning variables and stuff. So this is how variable works in Python. And the IDs thing, that should be clear. The ID memory address which we referred, that should be very clear. So say I'll make it clear one last time. So I define a name here. Say okay, the A is assigned to the string named string. Then now I reassign. Now I check the ID of A. Now I reassign the same string variable to some other name, like say mango. Now I check the ID of A. Now what will you think? Both are stored in variable A, so the ID should be same. But in reality, it is not. This is because we have one more concept called mutability and immutability. So we will cover this. So basically, strings are immutable. So what Python does is, if you create a variable named A and assign it to a string, so what Python does, it creates an object. Now what you're doing, you are using the same variable and creating another string on it, dereferencing and referencing another string on it. So what happens? Python create a new object again. It doesn't create replace in the same address or something, memory address. It creates an entirely new object in different memory address. So of course the idea of both should be different. Yes, it is different. So this is how the variable allocation and the address allocation, memory address allocation, everything works in Python. Everything is dynamic. So Hi. So now that we understand variables, now we can move on to functions. Um, Functions are the powerful part of any programming language. So it allows you to group code base into one structure uh, for a specific task. So you once you define a function, you need to call it, and then you can run as many times as you want. The function can be called as many times as you want based on the task. So every function should be having a separate desired task, and it should abide by it. That's how good function is evaluated. And so the how you define a function is that you need to use the keyword def followed by the function name followed by the parentheses. The parentheses contain values. So after the parentheses, you need to give a semicolon, which automatically then gives you the indentation, and you can write the body of the function. Every function need not have a return value, but for the function which you expect to have a return value, you need to like specify the statement return. So uh, this is a sample function greet. It returns the string hi. So if I just run it, I won't get any output because the function is not even called. So we need to call the function. So you call a function like this. Yeah. So now you can just see the response of the function. Suppose you want to create a function to add two numbers. Then like you can uh, specify to A and B inside the function. So you know, understand one thing. Functions become powerful when we pass data to them. So the values inside the functions are called parameters. This A and B is called parameters. Now you just add them and store them inside a variable result, and then you just return the result. Okay. So now you just call the function. So the same way how we did. So now here you pass two numbers. Say we can pass 6 and 3. Now you just print the output. This should sum up to 9. I'll now explain how it is working. So here A and B are parameters, but 6 and 3 are arguments. It is a very important difference. Parameters are in the function definition. So A and B are called parameters, but arguments are in the actual values which are passed. So in the function call. Now we can notice two things. Here we have used return result. Now it just prints me 9. You can ask, you can also use print, right? So suppose if I do print here, print result, see the difference in the output. I get 9 followed by a none. So what this none states, we used return initially. What return does? Return sends the value back to where the function was called. Here I used print. So since I used print, it has given me 9 followed by none. Before when I used return, it gave only 9. So print only displays it, does not send the value back. So if we want to use the output later for any manipulation which we want to do with the function, we need to use return. So return actually uh, gives every function will have return. So this is the main difference between return and print. So every function which has to return a value should have the return statement. So I am giving the return statement here. So yeah. Secondly, now we can go to the different parameters which are there inside the function. So first is the default parameters. So let's create a new function, def and greet again. So here we can like specify name equal to Raj. Okay. So and colon, and in the same way. So return here we want to return like hello. The name is Raj or something like that. So what we can do, we use a f string. So you might be knowing what a f string is. So f string is like you want to pass a value inside a string which you are defining. So f strings makes it easier. So what you can do is just give type f and then give the code. So you can here like type whatever you want. So um, my name is, then add a curly brackets. Inside the curly brackets, just specify the variable name which is here. So you can just specify name. Now this name will be name equal to Raj will be displayed here. So this is the use of f string. So I have given the f string here, and then now the same way we can print the function. So you can directly print it like this itself. So greet of parenthesis. That's all. You need not specify anything here. Um, there are two things. So if you don't specify anything, the default value name Raj is used. If you specify anything others, any other value instead of Raj is used. For example, I give here Roshan. So instead of Raj, Roshan will be used. So we can check both the things. So if you can see, hello, my name is Raj. Hello, my name is Roshan. This is the use of default parameter. This is default parameter, which means if you don't specify any argument, yeah, I mean, if you don't specify any parameter, the default parameter Raj is used. If you specify a parameter explicitly, the specified parameter is used. This is the default parameter. Now we need to understand positional and keyword arguments. So suppose in the same function I'm modifying. So here instead of Raj, okay, let's keep like this name and age, and then I'm giving here I'm passing here Roshan and age. I'm passing it as 21. Name and age is age. Okay, so I'm returning the value like this. This name links with Roshan and this age links with 21. So this is called positional argument, and the order matters. Here, see here. So once I run this function. Hi, so this is all about the positional arguments. Here you just specify the function call and the arguments in the same position where the parameters are defined. So this is not actually an ideal way in real-time code base, because you can't just you expect the developer to remember the position of the parameters defined. So there's another way Python allows to do function calls using keyword arguments. So instead of following the positions, you can do like age equal to 24 and name equal to Raj. So even in this way you can do it. This is called keyword argument. This way of passing function calls is called keyword arguments. So these are keyword arguments. So Python will get to know, okay bro, you have mentioned age equal to 24 and name equal to Raj. Okay, I'll then assign it to the respective parameters, and then I'll help you run the function. So Python will like help me run the function. Yeah. So this is the way it works. Secondly, there's another thing called variable arguments. So variable arguments are used in real-time code base where you explicitly don't know how many arguments a function can take. Suppose say you are making a transcription tool. So a transcription tool can take many arguments such as model capabilities, etc. So lot of things a transcription tool can take as argument. Here you can't like just mention two or three parameters which the function will take. Later on you might need to add more and more parameters, so that will be that would not be feasible if you use any position or keyword argument. So what you can do, you can add a variable argument. The variable argument is of two types. You can add a tuple or a dictionary. So there are two methods. So like let's take one example. So I'll create a function calculate. So what it will so here what I'm doing, first let's talk about the uh, method with tuples. Okay, so when I do like this, asterisk and args. So like okay, you can name it anything. I'm naming it args for the convention. So this star args means args is actually a tuple. which stores all the which stores all the arguments passed in the function call. So it is everything is stored in a tuple. So if you want to know the type of the args, I can just show it to you. So if I print type of args, this will actually print tuple. This is actually a tuple. Secondly, now let's do one simple calculation. So I just want to print the sum of the elements inside the tuple, which we are going to pass in the function call. So let's say I'm just summing up the summing up the elements in the inside the tuple, and then I'll just return the total value. So this is what my function returns. So here, if you can see, I'll just in the function call, what I'll be doing, I have not defined any specific arguments inside the function, so I can like pass as many elements inside this as possible. So I can pass 1, 2, 3, 4, 10, 15, 14, etc. Anything. So anything according to my wish, I can pass here. If I just run this function, it will say class is tuple and the sum of the elements. So yeah, so you can understand how the variable argument works here. The other way you can do is using a dictionary. So uh, this is actually used when you want to collect multiple positional arguments. So everything is stored inside a tuple, and yeah, basically this will be very useful in real-time code. Secondly, we can also use keyword arguments. So let's as we were discussing, similar to this, this tuple, we have another variable argument using dictionary. So that is called keyword arguments. So this args method is for collection of multiple positional arguments. Now uh, do we will initialize a dictionary which is for multiple keyword arguments. So this is how we can do it. How you initialize is that using double asterisk. Then for naming convention, I'm using the same keyword as variable. So this is actually a dictionary. Just to open the type I'm showing here. Yeah. So once we do it, suppose just I want to return the dictionary. The function main purpose is to return the dictionary. Basically, the dictionary is a collection of multiple keyword arguments. So in the function call, I'll do it like just display, and then I'll do it like name equal to let's take this Lakshmi this time, um, and age equal to let's take 30 this time, role equal to dev, salary equal to let's take. So yeah, similarly, you can specify multiple keyword arguments in the function call. N number of keyword arguments, all will be stored as dictionary as key value pairs, basically. So if I just run this, here you can see the class is det and it's displaying a dictionary. So yeah, this is how the variable arguments work, and these are extremely useful in the backend systems while you are writing any complex function or tools that requires n number of arguments to be passed. Everything in the backend is basically dictionary and JSON, so it will be very helpful during that time. Secondly, we need to know about the function scope. So let's talk about function scope. So all these you can refer the notes. All these are written here. So let's talk about function scope. Say if define a variable x equal to 10. Now I create a test function where I just I initialize the x variable to another value, and I print the value over here. Now I call the test function over here. Now I call the test function over here. Okay. Wait, let's return x. Now I call the test function over here, and now I tell uh, the value of x outside. So I'll just print x over here. Now, what do you think will happen? I have changed the value of the variable x inside the function, and in the global it's 10. So let's see what happens. So inside the function, I have made it x equal to 5, and I returned what is inside the function, which is returning 5. In the global scope, when I print x again, it's returning 10. So this means that the variable defined inside the function are always local. Variables defined outside the function are always global. Scope means where a variable is accessible from. So the scope of the variable x. Uh, so if it's global, the value is 10. If it's local, that is inside the test function, it is in some other value. Say I create another function test2. Here I define the value of x as x3 and I return x again. So now after now I print, call test2 function as well. Now what will happen? Oh, sorry, invented. Yeah. So now what will happen? Inside the test2, the value is defined as 3, and inside the test function is defined as 5. So this means that the scope means wherever the variables are defined, in that scope the variable will be accessible. So that is the meaning of scope. So in this function session, we literally learn how to define it, importance of indentation, parameters, arguments, scopes, keyword arguments, positional argument, keyword, etc. So all those we have learned, default values, default arguments, etc. So these are the backbone of Python, and literally we need all these to know while creating AI models, backend APIs, etc. Now, now we move to the control flow section. So control flow like conditional, if else, else if, looping, while loop, for loop, do while, etc. All those are very important. So looping is done everywhere. So there are few keywords which we need to know: if, else, elif, while, for, break, continue, etc. So let's talk about the control flow. Control flow actually decides which code runs, when it runs, and how many times it runs. So without control flow, the programs would just execute line by line without any decision making. So without any decisions, if there's a program, it's actually absurd. You can't write a program without making decisions. The main aim of problem solving is making decisions. So the simplest form of control flow is like if statement. So it checks a condition. If the condition is true, it executes the block. If the condition is not true, then it does not execute the block. If it's false, it just skips it. That's all. So the basic example is like age equal to int of input enter age. Now I like do it like if age greater than equal to 12, uh, print happy. If age less than 12, or you can make it like else, print sad. So what will happen? This is a basic conditional. So if you enter the age greater than or equal to 12, you will print it asks you to print happy. Anything which doesn't satisfy this condition, it will print sad. So if I enter the age as 15, it will print happy. So yeah, see, this is a basic conditional check which we do. And indentation actually matters here as well. After the colon, you just get indentation. So this is the basic principle in Python. So there's another thing called elif. So elif means, see, there are multiple if conditions you need to tackle. So elif basically is for else if it allows multiple conditions. So I type here elif age, um, age is equal to 10. Then you print age is 10. Else sad. So Before, what was happening, if the age is just greater than or equal to 12, it will print happy, else it will print sad. Even for 10 it will print sad. Now I am having one extra condition, elif, which means that if age equal to 10, you need to explicitly print age is 10. So I am defining age is 10. Okay, so age is 10. Age it will print age is 10. So this is the basic use of elif, and it allows multiple conditions. So there's another thing called while loop. So the while loop runs as long as the condition remains true. It is actually useful when we don't know exactly how many times the loop should run. Basically, you need to loop through only a condition, then use while loop. So let's take an example. So I define the count for while loop. You should actually define a count beforehand so that when the count fails or the condition fails, you just exit out of the loop. Else, you'll be facing indefinite loop conditions. So you need to define the conditions properly. If the condition is always true, it will keep on executing without any unlimited loop. So that should not happen. So I'll define like while count is less than or equal to 5. Print count count plus equal to 1. So what I've done is I initialize the count as 1. Then what I've done is while count is less than or equal to 5, until that I'll keep on looping. So if you see, if I'm keep on incrementing this count, let's see what happens when I don't increment first. So when I remove this, the loop will be endless and will keep on running because the condition never fails. When it's always 1 and it's always less than or equal to 5, then why should the loop exit? That is why we need a condition here saying count plus equal to 1, which actually means count equal to count plus 1, which means for every iteration count value will be iterated increased by 1. So once it reaches 5, when it's equal to 5, it will stop the loop. If you can see 1, 2, 3, 4, 5, it equals 5, then in the next iteration it is 6, so it has stopped the loop. So this is how a while loop works. Basically, if you don't update the condition inside the loop, you create an infinite loop. So yeah. Second, the other thing which we are having is for loop. Let's start with the for loop. So as said, for loop is actually used when you want to iterate over a sequence. So a sequence can be anything: a list, a string, a tuple, a range, etc. So let's first code using range. So this is how you define a for loop for I in range. So this I, J, K, etc. by naming conventions, all these are increment variables. So you need them to increment over the loop, over the range, over any sequence. So suppose if I keep it 4 and a colon here, so indentation happens by default. So what this range in 4 means? Range is like it will start from 0 and go until n minus 1. Basically, here if I mentioned 4, it means it will go until 0, 1, 2, and 3. So this is the range. So it can take start value, stop value, and a step value. So if I do it like 2 comma 10, this will iterate from starting 2 and goes until 9. So n minus 1, 10 minus 1 is 9, goes until 9. So 2, 3, 4, 5, 6 till 9. You can also have a step value. So step value in the sense how many step, what is the step? So basically if I keep the step, by default it is 1. So if I keep it 2 here, so it will now work like starts from 2, then goes into the step value is 2. So from 2 it will go to 4, 2, 4, 6, 8, and then in 8 it will stop because after 8 it goes to 10. It doesn't include this 10 is not inclusive, so it's exclusive. So till 8 will go. So 2, 4, 6, 8. This is how the step value actually works. So this is how the range works. Now if I want to print what is that, I'll just print and show you how it is. So yeah, so as you can see, 2, 4, 6, 8. This has been shown, given. So there is, now we can iterate through a list as well. So let's take one example like list equal to 1, 2, 3, 4, and 5. So if you want to iterate over this, you can iterate over the list as well. So for I in list 1, you can directly keep the list as the sequence. No need to specify any range. Print I. You can do any operations in this.
any functions in this. So you can just iterate over the list like this. Then you can iterate over a string as well. So suppose I create a string, string1 equal to Python. So if I want to iterate over the string, I can just keep it like string1 and then print I. The characters of the string will be printed. So this is how it works. And then there's another thing called break and continue. So break and continue are very vital parts in the loop control. So we want to control the loop execution, then we can use break and continue. Break actually immediately stops the loop. For example, for I in string one, if I specify if I equal to say t, so what I am telling is if the character is actually t, then I am instructing the loop to break, which means the loop will actually break. Wait, I'll just do it here. So yeah, first you print the character. If the character is t, just stop the loop. That's all. After that, the loop won't run. So if you see here, pyt. Once the t is once Python recognizes t, it breaks the loop and it comes out of the loop. But there's another thing called continue.
Yeah,
Yeah.
so
So
let's
let's
now
now
see
see
the
the
other
other
thing,
thing.
continue.
Continue.
Continue
Continue
keyword.
keyword.
So
So
similar
similar
to
to
break,
break,
continue
continue
is
is
like
the
the
loop
loop control
control
mechanism
mechanism
keyword.
keyword.
So
So
break
break
just
just
immediately
immediately
executes.
executes,
I
I
mean,
mean,
comes
comes
out
out
of
of
the
the
loop,
loop,
stops
stops
the
the
loop
loop
entirely.
entirely.
But
But
continue
continue
does
does
not
not
do
do
that
that
thing.
thing.
It
It
will
will
just
just
skip
keep
the
the
current
current
iteration
iteration
and
and
move
move
to
to
the
the
next
next
iteration.
iteration.
That's
That's
all.
all.
So
So
we
we
will
will
take
take
one
one
example.
example. Um,
So
so
suppose
suppose
if
if
I
I
say
say
for
for
I
I
in
in
range,
range, 6,
6, then
then
I
I
keep
keep
it
it
like
like
if
if
I
I
equal
equal
to
to
3,
3,
continue,
continue,
and
and
then
then
I
I
ask
ask
to
to
print
print
I.
I.
So
So
what
what
happens
happens
is
is
it's
the
the range
range
is
is
6,
6,
so
so
it
it
means
means
it
it
starts
starts
from
from
0
0
until
until
5,
0,
0,
1,
1, 2,
2,
3,
3,
4,
4,
and
and
5.
5.
So
So
it
it
will
will
loop
loop
until
until
0,
0,
1,
1,
2.
2.
Once
Once
I
I
becomes
becomes
3,
3,
this
this
continuous
continuous
statement
statement
executes,
executes,
which
which
means
means
the
the
iteration
iteration
is
is
stopped.
stopped.
So
So
the
the
3
3
will
will
not
not
get
get
printed.
printed.
So
So
what
what
will
will
so it will
it
go
will
to
go
the
to the
next
next
iteration,
iteration,
which
which
is
is
I
I
equal
equal
to
to
4.
4.
4 will
4 will
get
get
printed,
printed,
5 will
5 will
get
get
printed.
printed.
That's
That's
all.
all.
So
So
the
the
loop
loop
will
will
so this is how it
so
is.
finalizing a control flow statement. We'll just take one simple example.
So
So
using
we
we
can
can
just
just take
take
login
login
system
system
example.
example.
So
So
suppose
suppose
if
if
we
we
by
by
default
default
say
say
one
one
two
two
three
three
four
four
five
five
is
is
the
the
correct
correct
password,
password,
and
and
then
then
you
you
want
want
to
to
like
check
the
you
you want
want
to
to
make
make
a
a
login
login
system.
system.
So
So
what
what
we
we
can
can
do
do
is
is
we
we
can
can
just
just
initialize
initialize
items
items
variable
variable
equal
equal
to
to
0.
0.
So
So
here
here
think
think
of
of
it
it
like
like
this.
this.
You
You
can
can
use
use
a
a
while
while
loop.
loop.
Why?
Why?
You
You
know
know
a
a
condition
condition,
password
password
should
should
be
be
1
1,
2
2,
3
3,
4
4,
5,
5,
and
and
you
you
know
know
the
the
attempts
attempts
should
should
be
be
in
in
some
some
limit.
limit.
So
So
you
you
can
can
give
give
the
the
attempts
attempts
as
as
3
3
or
or
5.
5.
After
After
that
that
attempt,
attempt,
it
it
should
should
fail.
fail.
The
The
login
login
should
should
fail.
fail.
So
So
or
you
you should
should
go
go
to
to
the
the
recovery
recovery
mode,
mode,
anything.
anything.
So
So
you
you
know
know
the
the
conditions
conditions
beforehand.
beforehand.
So
So
here
here
it
it
is
is
advisable
advisable
to
to
use
use
while
while
loop.
loop.
So
So
this
this
is
is
how
how
we
we
should
should
think
think
where
where
what
what
loop
loop
we
we
should
should
use
use,
while
while
or
or
for
for
in
in
whichever
whichever
conditions
conditions
we
we
have.
have.
So
So
suppose
suppose
say
say
I
I
am
am
giving
giving
3
3
as
as
the
the
maximum
maximum
attempts.
attempts.
So
So
while
while
attempts
attempts
is
is
less
less
than
than
3,
3,
I am
I'm
asking
asking
the
the
user
user
to
to
enter
enter
the
the
password
password
as
as
input,
input.
uh,
Uh,
the
the
int
int
of
of
input,
input,
yeah.
yeah.
And
And
then
then
I am
I'm
giving a
giving a
condition
condition
like
like
if
if
password
password
equal
equal
to,
to,
I'll
I'll
just
just
define
define
it
it
differently,
differently.
uh, temp.
Temp.
Okay,
Okay,
so
so
temp
temp
password.
password.
If
If
password
password
equal
equal
to
to
temp
temp
password,
password,
then
then
print
print
access
access
is
is
granted.
granted.
Which
Which
means
means
it's
it's
a
a
condition
condition
check.
check.
So
So
if
if
the
the
password
password
is
is
actually
actually
the
the
original
original
password
password
one
one
two
two
three
three
four
four
five,
five,
then
then
you
you
can
can
tell
tell
access
access
is
is
granted.
granted.
Then
Then
you
you
can
can
just
just
break
break
through
through
the
the
loop.
loop.
So
So
you
you
can
can
just
just
break
break
the
the
loop.
loop.
That's
That's
all.
all.
No
No
need
need
to
to
do
do
the
the
login
login
flow
flow
again.
again.
Else
Else
you
you
can
can
define
define
the
the
condition
condition
like
like
if
if
the
the
password
password
is
is wrong,
wrong
wrong
password,
password,
you
you
can
can
increase
increase
the
the
attempts.
attempts.
So
So
attempt
attempt
to
to
attempts
attempts
plus
plus
equal
equal
to
to
1,
1,
and
and
then
then
you
you
just
just
keep
keep
on
on
increasing
increasing
the
the
attempts.
attempts.
So
So if atoms crosses 3 or equals 3, we can say. If atoms equal to 3, we can just tell print uh, recovery mode initiated. So this is a simple example of a login flow which we can do. So if I just want to, I'll give the input as 1 2 wait, times, sorry, yeah. So here I have different variable. Yeah, now we can check. Yeah. So first I give the password as 1 2 4 5 6 7. This is wrong password. Now this is also a wrong password. Now if I give wrong password again, it will say wrong password and then recovery mode initiated. Why? Because the atoms is equal to 3. Here in the while loop I have mentioned when atoms is less than 3 only, you should ask 3 thing. So this is a sample implementation of a while, how a while loop break statement everything works. So if you want to see how the break statement works, see. So suppose I correctly type the password 1 2 3 4 5. That's all. It will print access granted and will break out of the loop. That's all. So this is how conditional statements work, and this is how the control flow is used in the real systems, real-time systems. This is the basics. So if we get to know the basics, then decision making and looping, everything will be much easier in the code base which we do. So without all these, the program cannot make decisions. Now we will go to the next section, which is functional programming. So hi,
Hi,
so
so
let's
let's
now
now
explore
explore
functional
functional
programming
programming
concepts.
concepts.
So
So
these
these
are
are
actually
actually
covered
covered
at
at
the
the
end
end
of
of
any
any
Python
Python
course
course
or
or
at
at
the
the
end.
end.
So
So
people
people
might
might
think
think
these
these
are
are
not
not
important
important
and
and
try
try
to
to
neglect
neglect
it.
it.
But and
And
they
they
sometimes
sometimes
also
also
feel
feel
too
too
overwhelmed
overwhelmed
regarding
regarding
Lambda
Lambda
functions
functions
or
or
something.
something.
But
But
in
in
turn,
turn,
it's
it's
very
very
simple
simple
and
and
it
it
just
just
makes
makes
the
the
code
code
base
base
lighter.
lighter.
So
So
it
it
might
might
sound
sound
complicated,
complicated,
but
but
it's
it's
actually
actually
simple.
simple.
It
It
actually
actually
treats
treats
function
function
as
as
first
first
class
class
objects,
objects,
which
which
means
means
functions
functions
can
can
be
be
passed
passed
around,
around,
stored
stored
in
in
variables,
variables,
and
and
even
even
used
used
in
in
other
other
functions.
functions.
So
So
that's
that's
the
the
main
main
idea
idea
of
of
function
function
programming.
programming.
So
So
let's
let's
start
start
with
with
lambda
Lambda
functions.
functions.
So
So
basically,
basically,
we
we
define
define
functions
functions
using
using
def,
def,
but
but
sometimes
sometimes
we
we
just
just
need a
need a
simple
simple
one-line
one-line
function.
function.
For
For
that,
that,
why
why
should
should
we
we
like need
need
to
to
write
write
a
a
log
log
function
function
initialization
initialization
using
using
def,
def, then
then etc.
etc.
All
All
those
those
big
big
things.
things.
Why
Why
do
do
we
we
need
need
to
to
do?
do?
So
So
we
we
can
can
use
use
lambda
Lambda
function
function
as
as
an
an
anonymous
anonymous
function.
function.
Basically,
Basically,
it
it
has
has
no
no
name.
name.
For
For
example,
example,
if
if
you're
you're
creating
creating
a
a
function,
function,
say
say
def, you
you
are
are
creating a
creating a
square
square
function.
function.
Okay,
Okay,
so
so
def
def
square
square
of
of
x,
x,
and
and
then
then
you
you
just
just
return
return
x
x
into
into
x.
x.
Then
Then
you
you
just
just
print.
print.
So
So
okay,
okay,
so
so
this
this
is
is
a
a
square
square
function.
function.
You
You
can
can
just
just
uh, create
create
it
it
like
like
this.
this.
But
But
using
using
lambda
Lambda
functions,
functions,
it
it
will
will
just
just
become
become
one
one
line.
line.
See,
See,
the
the
same
same
implementation
implementation
of
of
how
how
using
using
lambda
Lambda
function
function
becomes,
becomes,
you
you
just
just
initialize
initialize
a
a
variable
variable
square
square
equal
equal
to
to
lambda.
lambda.
Then
Then
what
what
you
you
do
do
is
is
you
you
can
can
give
give
the
the
expression
expression
over
over
here
here
x,
x,
then
then
give
give
a
a
colon,
colon,
then
then
give
give
the
the
body,
body,
what the
what the
body
body
should
should
look
look
like.
like.
So
So
x
x
into
into
x.
x,
That's
that's
all.
all.
That's
That's
all.
all.
This
This
one
one
line
line
is
is
the
the
function
function
which
which
you
you
are
are
defined
defined
here.
here.
No
No
need of
need
comments
of comments
return
return
anything,
anything,
nothing.
nothing.
So
So
just
just
now
now
print
print
this
this
square
square
the
the
same
same
way
way
how
how
you
you
call
call
it,
it,
square
square
of
of
say
say
5.
5.
It
It
will
will
print
print
25.
25.
So
So
how
how
this
this
how
how
simple
simple
lambda
Lambda
function
function
is.
is.
Both
Both
gives
gives
the
the
same
same
implementation,
implementation,
but
but
lambda
Lambda
is
is
actually
actually
shorter.
shorter.
You
You
know,
know,
lambda
Lambda
function
function
can be
can be
used
used
when
when
the
the
function
function
is
is
small and
small and
it's
it's
used
used
temporarily,
temporarily,
and
and
if
if
your
your
function
function
is
is
going to
going
be
to be
passed
passed
into
into
another
another
function,
function,
it
it
keeps
keeps
the
the
implementation
implementation
lighter.
lighter.
Secondly,
Secondly, we
we
will
will learn
learn
about
about
map
map
function.
function.
So
So
map
map
actually
actually
applies
applies
a
a
function
function
to
to
every
every
element
element
of
of
a
a
sequence.
sequence.
So
So
instead
instead
of
of
writing
writing
a
a
loop
loop
manually,
manually,
map
map
handles
handles
it
it
internally.
internal.
Suppose
Suppose
just
just
a
a
list
list
numbers
numbers
equal
equal
to
to
1, 2,
1, 2,
3,
3,
4,
4,
5,
5,
and
and
6,
6.
and
And
I
I
just
just
keep
keep
a
a
separate
separate
result
result
list
list
to
to
store
store
the
the
results.
results.
Now,
Now,
in traditional programming, what we'll do for I in numbers,
numbers,
what
what
you'll
you'll
do,
do,
you'll
you'll
do
do
result
result
dot
dot
append,
append,
and
and
then
then
you'll
you'll
say
say
you
you
append
append I into 2 basically. Okay, so you append the elements inside the numbers and multiply every element to 2 and then append into the results list. Yeah, result list. So if you print result, what you know, basically now guess the result what will be. So this will be the result. Now with map, this entire code becomes very short. Now implementation using map. Okay, so you have initialize the number variable here. Okay, I reinitialize it here. You have initialize number variable here. So what I'll do is I'll define a variable result equal to result. Basically this list I'll directly define this variable and then list of map. Then what I will do, I'll create a lambda function x into 2, which means the element x should be treated as x into 2, and then the I trouble is the numbers list which we have defined. Yeah, so basically this is how the map function works. You create a map of the lambda function. Lambda function is very simple. You just need to multiply every element, treat this element as x, and then apply into 2. That is multiply every element by 2, and then the IEEE you have to pass here, which is numbers. That's all. If you just print the result at the end, I'll remove this. Okay, I'll keep it so we can see the same thing will be printed over here. So instead of writing this much code, you can just write using one line. So this is the power of functional programming in Python. So we should understand two things. A map takes, a function and a sequence. A sequence is like an iterable object. It can be list, dictionary, anything. So it takes a sequence and a function. Function is you can directly pass a function over here, or you can make a lambda function. But lambda function seems easier. So you can just pass a lambda function and then a sequence. That's all. So this creates you the element output. And the next thing is reduce. So uh, okay, next we'll go to filter. Then we will come to reduce. Filter actually, select the elements based on a specific condition. Suppose, uh, say you need to keep only the values inside the list which is divisible by 2. So you what you will do, I mod 2 equal to 0, then append it in a separate list and then keep. So without filter your code again becomes very big. So with filter what we can do is same numbers list I'm taking, and then I'm defining a new variable. So then I take the even list equal to list of. Now instead of that I'll use the function filter. So if I take filter, it will again ask me the two parameters, that is function and the sequence again. So here in the lambda function I'll be defining lambda x colon. Now this time what I'll be doing is, instead of x into 2 I'll be doing x mod 2 equal to 0. I'll be defining the condition what the x should be following. Then I will just give the iterable again the numbers over here. Now what will happen? This filter function will filter the filter using this condition, that is in which what all numbers are like divisible by 2, and then place it in this even list. And now if you print this even list, we will be getting the numbers which are divisible by 2 from the list. So instead of like complicating over for loop and then iterating over the sequence, we can just use one line function to just print the results and get the desired results. This is actually very useful when you want to get the analysis of the model. If you want to filter a specific constraint or a specific parameter from a given model or a data set, and then you want to like print it. So that time all these functions will be very useful instead of just randomly iterating over a sequence or a loop. So the other thing is reduce function. Even the reduce function is the same. We need to use the function on iterable, pass the function on iterable as parameters, and then use it. But for reduce function, we need to do one import. So what we can do is import reduce function. So what to do is import sorry, from func tools import reduce. So this is the thing which we define, which we import before using reduce. So again, you take the numbers list I have defined here. So we can maybe create a list called total equal to reduce of lambda. This time, say suppose you want to do the sum inside the list. So what you can do is you can define lambda function like this: a comma b, lambda a comma b colon a plus b. This means that you just sum the corresponding elements inside the list. So inside the iterable, which is numbers list. So it will take two arguments, two parameters a comma b. So let's take one and two. So it will take one and two, and then do the sum one plus two. It becomes three. Then after it is three, it will go to the next until there's iterable element in the list, and then finally you can print total. Now you'll be getting the final total, which is 21. So if you sum all this, the answer is 21. You will get 21. So basically, if you want to keep combining values and then arrive at a final result or a value, you can use reduce function. So there is an important question: why and where to use these functions. So it's not necessary that you should always use map, filter, or reduce. For beginners, like normal loops are very much readable, but these functional programming is used for intermediate level programmers who just want to simplify tasks. In data processing and AI pipelines, function programming is very much used. If you see any code, all these are like widely used. So while working with large data sets, transformations, or any pipelines, you might need to use this. So yeah, this is the gist of the functional programming, how it is used, whatever it is used, and you can refer the notes as well. So next, we will go to the data structures, strings, lists, tuples, and dictionaries. So let's move on to the data structures.
Hi, so now let's move into strings. So here I have defined this is how you define a string. So you just put double quotes and then define a string. That's actually a proper way to do it. If you want to define a character, you can define it like this. This is how you should actually do it. But you can use either of them. So even a single quotes is fine. And secondly, every string will be having an index. So suppose if let's take this example. Suppose if the string is named as dog. So this is how indexing will work. If you want to know the length of the string first, let's say string 2 equal to say dog. You can like uh, know the length of the string by using this len function. So len of string 2. This will actually give you the length of the string 3. So in general, indexing works like you start from 0 and go until n minus 1, the positive index I'm telling. So it'll go until n minus 1. So index will be 0, 1 and 2. 0 for D, 1 for O and 2 for G. Similarly, the strings will get indexed. And there's a negative index as well. So the for last position will be given minus 1 and the second last will be given minus 2 and so on. The string will go until minus 1 to minus n. So that will be the negative index basically. Now there's a thing called string slicing. So here, in the indexing. So first, if once you understand, once let's understand indexing. So if I want to print the character O inside the string 2, what I can do is string 2. Now we need to know it properly. Uh, First position is 0. The next subsequent position will be 1. So you just need to add the value 1 here over here and O will get printed here. So yeah, that's how we need to access the index variables and print accordingly. Second one is string slicing. String slicing is like fundamental thing to know. So in string slicing, let's say somewhat bigger string. So let's say string 3 equal to Python. org. Okay, so let's take this string. Now, now if you want to slice it, by default, the start by default slicing will be having start. So this will be the, I'll just tell how to start, stop, and then step. Okay. So these are the fields this slicing will be having. Start is the start index. So if you want to start from the index, if you want to print th, then the start index will be 0. Start index is always inclusive. So I'll put 0 here. Then you want to pyth, you want to go until h, 0, 1, 2, 0, 1, 2, 3. So h is the third index basically, but this index is not inclusive. So if you want to print h also, you should go until index 4 so that you can print pyth, and by default the step value is 1. You need not define it. So I'll just remove this. So 0 to 4. Now if you print this, it will print pyth. Yeah. So this is how indexing as slicing actually works. You can print over a range of sequence you can print. So if you want to reverse a string, so these are main slices which you need to know. If you want to reverse a string, you can give colon colon minus one. So it means the minus one is a step value, so it will just reverse the string. So I'll just print this and show Python org will be now reversed. Yeah. So this is used for the palindrome checks and all. So in the conditions, if it's a palindrome or not, you can use these conditions and check it. And there are positive slices and negative slices. So if all depends on the step value only. So if the step value is like positive, if the step value is positive, you can make the uh, start index before your stop index. And if the step value is minus 1, you need to make the start index to the right of the stop index. Basically, what I'm trying to tell is, let's take an example. So if I want to print string 3 of, let's keep the step value positive. So if it's plus 1, uh, what you can do is you should always it should always go from left to right if the step value is positive, which is 1 by default. So I'm not mentioning it. So the start value should always have a lesser index than the stop value. So 0 colon 4, which means 0 is index is less than 4 index. 0 colon 3, 0 colon 5, or 1 colon 5, or 2 colon 5. In this only it will get printed. If the start is more than the stop, basically if I put 4 here, and then if I give colon here, this will actually print an empty string. Yes, this will printing an empty string because the start is more than the stop when the step is positive. It should not be like that. So by default, understand it like this. Secondly, because that's how Python is designed. So uh, if you keep the start index as 4 and you want to iterate until 1, you can go until 1 itself. So that will be absurd. So Python will just print a blank screen. Suppose say the step value is negative. So now let's cover the negative slices. So we were speaking about the negative step value. So for the positive step value, by default, the start index should be less than the stop index because you move from left to right, and that's how the logic works. For negative slices, you go from right to left. Basically, if we take this string uh, over here. So here it starts, it's negative. So you go from God, not Dog. So if you want to iterate, if you want to do the slicing from, if you want to print G and O, what you'll do? You should not print. You should not keep minus 2 as the start index. You should keep minus 1 as the start index and minus 2 as the stop index. So it's going from right to left. Then only this step value is minus 1 and the reverse way can be printed. So we'll just see how it is working. So if I keep the string 3 colon, well, first let's keep the step value minus 1. So it will get reversed. Secondly, I keep the start value as minus uh, 1, and then I keep the stop value as -3. So what it means, -1 is the start value. So start printing from G and go until the index which is -3. So this will get printed. If you see, this will get printed. Yes, GR is printed. You are getting a blank over here. This is for this. So when the step value is 1, this is by default 1. You need not mention 1 here. So by this default 1, so I haven't mentioned. So when the step value is by default 1, you need to have the start index less than the stop index. In negative strings, you need to do it in reverse. So say if I do it like this, see, suppose print string 3, and then I keep the negative slice once again. But instead of doing it like going from right to left, I make it like -2 and -1. This will give me a blank empty string, so it won't print anything. So if you can see, it will give me empty string because the iteration can't happen. You are going from right to left. You are explicitly telling it to go from right to left, but you are not giving the index properly, so it won't work. So this is how the slicing works. This idea is common for list as well as string. So even for list, you have the slicing. So it is common for both string and the list. And there are few string methods that you can use. So, for example, um, the basic concept of a string that I have told before. So, name equal to say Python, and you want to like mention it. So, print. You just what you do is you give f. No, what you do is you first give f, then give like this, then print the programming language I like is, then open a curly bracket and then specify the name. That's all. Use Python. Now it will automatically fetch Python. So this is how string works. It's very important, vital component in string methods. This you'll be using in all over AI codes, like for example for prompts, etc. In every field, you'll be using this string. Other than string, you can also use dot format method. So yeah, you can also write it like uh, the programming language I like is. You can just create an index like this. So say 0, and here you can do dot format and then specify the thing which you want to add. So this Python. So both are same. Both are doing the same thing. You can either use dot format or you can use string. So depends on how you want to be, how you want the structure to be. So you can use anything. The F strings are like modern and clean way to format strings. So F string is preferable, but anything is fine. And other methods like split, join, find, replace, everything is like given over here. You can just give it a read. The notes will be shared, so you can just give it over here. These are the main methods of the string which are used. And coming the methods, the term methods, don't take it as a fancy thing. Method is basically function that a module can do. So string is a Python module, so that module has different functions which can be done. So this dot lower, dot upper, dot strip, dot join, replace, etc. All those are methods of string. That's all. Nothing to get complicated with the term, fancy term method. Secondly, this dot split that is used in many places. This method dot split. So suppose you want to if there's a string, say I love Python, and you want to strip off you want to split the string based on any character. Basically, if you want to if there's space here, you need character space here, so you want to split the string based on space. What you can do is um, split actually returns a list, so we can just create a variable like split one. Okay, we want equal to string to dot split. You can just give this space as a split, and then if you just print split one, it will give you the separate list. I love Python, so it will all will get separated. So all these are used in various programming logics. So all these are very, I mean, basic things to know. So you can just know it. And string dot find, and if you specify the character, it will return the index value of the character, and you can replace the string with one with another. But here one more important concept when it comes to replace. So now see, I have defined a string named Python. Now if I do the function string name, name again, I define the name itself. Name equal to name dot replace. I replace Python. I mean I replace P with you know say you P with O. So uh, take P and replace with O. Okay, so I do this. Now, if I print name, it will give oh Python. Okay, that's fine. What we have to look into is now. I will like print the ID first. Okay, print ID of name. After replacing, let me print the ID of name. Okay, both are the same variables. Both are same. I have just replaced in the same variable only. But the results you might be seeing is different. Yeah. So the results you'll be seeing is different. So there are two different IDs which you have been getting. So initially name equal to Python has a different ID and this has different ID. So what this means? So this means that Python actually creates string as objects. So string is immutable. Immutable in the sense you can't change the yeah, elements inside string. You can't directly index and change this. Same this name dot replace method. You can't do it like name of 0 equal to O. That will give you an error. You can't do it. But this is working. So if this is working, what it means, Python has created a new object named name with the value which you are asking it to replace. So, which is why you are getting two different addresses. So, this is how Python programming works. In any other language, you actually can't do this at all. But in Python, you can take control over the objects you create and then you can work on it. So, this is a very important vital thing which has to be known. So just give it a read. And okay, so this very important thing to be known. And secondly, we can go to list next. So this is how we define a list. Numbers equal to 1, 2, 3, 4. You can even have multiple data types over here and Raj, etc. You can have multiple data types, integer, a float, string, etc. Anything inside this, it can contain multiple data types. Secondly, these are the functions inside the list. So you can do is numbers equal to 1, comma 2, comma 3. You need to add any uh, number at the end of the list. You can just give numbers dot append, and then you give 4. 4 will get appended at the end. Yeah, so we want to then insert anything. So numbers dot insert 1 comma 10. So instead of like after the element 1, uh, after the in the element at the index 1, you'll have the element 10 inserted. So if you want to have numbers dot insert 2 comma 20, and then you print numbers at the index 2, you'll have 20 inserted. So this is how insert function works. Yeah, so like when we give numbers dot remove, and then say if you want to remove 4, you just tell, and then 4 will be removed from the list. So this is how the things work in list. So you can remove elements and keep playing, add, insert, append, etc. So append adds element at the end, and then insert adds it as at a specific index or position, and remove deletes a value. So this is the major things which you need to know. And you can sort a list as well. So if you want to sort a list, numbers dot sort, you will get the sorted list at the end. And then you can also sort it ascending, descending, etc. any way you want. And this numbers dot sort doesn't have a return value, so no return type. But there's a thing called sorted. So now sorted returns a sorted list. So for a sorted list, you can like just do sorted of numbers and then print sorted list. It will just print you a sorted list. So both does the same, but sorted function has a return type. Okay, so this is all about list and basic functionality. So one more thing with respect to list. So if I so now I want to just show the mutable property of lists. So how lists work differently when you pass it as a argument in function. So this is a very important thing to know. So suppose I create a function named list, and then I pass a list into this passed list argument into this, and then inside the past list what I do, past list dot append, I append 5 into this, then I return the past list. Okay, here I create another list 3. Okay, so say list 3 equal to 1 2 3 4 and 4, and then I just do the function call, basically print list 2 of list 3. Okay, so first let me print let me return the past list, then we can I'll show the property. So the past list returns 1 2 3 4 and 5, but in the global the list 3 is defined as 1 2 3 and 4, right? So what should it return? It should return 1 2 3 and 4 only, but let's see what it returns actually. Both returns 1 2 3 4 5 same way. You might be surprised how the scope is global, local. We were discussing about it before, but why it is working differently in list? This is because list does not create any separate objects like integer or strings. Integer and strings, they are immutable, so different objects are created when you modify the things. But list is mutable, so even if you modify a list inside a function, even if it's local or global, it will follow the same logic of mutable property. So if you modify a list, say the corresponding list in the function, if you print it in the global, same modification will be there. So this is how it will work. So we need to know how this mutable property of list when we pass to function. And now let's move to tuples. So tuples are like given like this. So cos equal to, you just give a parenthesis and then specify the value. Same like what we did to what we did to the arguments. Variable arguments, which takes multiple positional arguments. Same way you can just define a tuple. They are similar to lists, but they are again immutable. You cannot modify a tuple. Basically, you cannot do like chords of one equal to some value. This will raise error. You can't support item assignment. But whereas in list you can do it. Suppose if I take it as a list and chords of one equal to two, you can do it. You list are you didn't raise any error. See, so if you print chords, it will show the updated thing. So it will just uh, modify it, so it doesn't do any changes. Uh, it doesn't. I mean, it doesn't give any error. But whereas tuples, you can't modify them. They are immutable. So these things has to be kept in mind. Similar strings, they can be modified. Secondly, the same string operations can be done here. Basically, chords dot count of a specific element, and then chords dot index, and then you get to know the index of the element. So if you get to know the index, you know to get the count. All those can be done. So if you want a data which should not change in any program, use a tuple. Yeah. So this is a good data structure as well. Then we move to dictionaries. So dictionary. So all tuple list everything is done. So let's move to dictionaries. And these are the few things which I told. So they are ordered and immutable. So all these. So let's move to dictionaries now. Um, Dictionaries are like it stores data as key value pairs. So the keys of the dictionaries must be unique. They are very useful in backend systems. So I'll just like go to the dictionary how you can create it. So suppose this is how you create a dictionary. Okay, so you can keep the name as generally the keys are enclosed with quotes like the string keys are enclosed with quotes. So you need to keep that in mind, and you can keep it Raj, and then you can keep the salary as get 12,000. This is how you create a dictionary. Okay, so if you want to access the elements in the dictionary, so you can even if you want to access the value of a particular key, what you can do is print students dot. If you want to suppose access the value of the key name, you can do like students dot name, students dot get, and you can pass name. Sorry, student dot get name. So this will print the value of the name here, which is Raj. Let's check it. Yeah, so Raj is getting printed. And if you want to get get all the keys inside the dictionary, what you can do is student dot keys. Same way you can do for student dot values as well. So values also you can just yeah. Well, it will be in the form of dict values. This is how the structure is. You can convert it into a proper dictionary and then display it. So that's not an issue. So you can do it. And if you want to update any specific key with any different value, so suppose a student, if you want to add, if you want to update the dictionary with a new parameter, so what you can do is student dot update. So I have given the name and salary. I didn't add age. So if you want, I can add age, and then the same way, age is 30. Yeah. So I can do the same way. Yeah. So inside this flower brackets, you can just add the same way how you initialize the dictionary and then update it. So if you print student once again, yeah. So now you can see the new key value per age and 30 has been added. Uh, so to conclude, dot get actually retrieves the value, dot keys returns the keys, dot values return the values, and then if you want the key value pairs, you can do it like student dot items. This is majorly used in looping. So this student dot items are majorly used in loopings to in loops. So you can get the value as key value pairs and then iterate them. Dictionaries are also mutable and iterable, similar to like list. This returns key value pairs. Basically, yeah, if you can see the key value pairs are returned. So the other thing is that what other thing is yeah, these are the main things which are used in dictionaries. So if you want to loop through a dictionary, if you want to loop through it, you can do. Suppose if you want to loop through a student's dictionary, so for key, you need to define two iterables over here because dictionary has two values, key and values. So for key comma value, in this is how you iterate in a dictionary, student dot items, and then you can do it like print key, print, you can do like print, use the same string concept f, then the key is key, and the value is value. You can just print it and then check. That's all. Let's run and check it. Yeah, so the key is name and the value is Raj. The key is salary and the value is 12,000. The key is age and the value is 30. So this student dot items, you just keep it in mind. This will be used in looping the dictionaries and iterating the dictionaries and in backend systems for entirely. So this is the main thing. And now we can move to JSON file handling. So JSON file handling is also very important and is very similar to dictionaries. So this is JSON file handling is extremely we have done Tuples. So yeah, JSON and further. So JSON file handling is very important for backend APIs and AI systems. So we can write a sample JSON like this. I'll just create a sample JSON file. That will be easier, right? So I'll just create sample.json. Inside the JSON file, let's have these fields. So uh, name, let's keep this Shyam this time, and then you add, you know, marks equal to, I mean, colon anything like you say 90. Yeah, so let's have this sample JSON. So this will create a sample JSON. In real world programming, JSON actually stands for JavaScript object notation. So it is the data format which is used to exchange the data between systems, front-end systems, back-end systems, etc. So if your backend wants to communicate with front-end, so what your does is your backend actually gives a JSON file like this. You actually call it payload. So if you want to connect it to your front end, you need to pass this information to the front end. Let's say any button you create, you need to pass this information to it so that okay, it recognizes this is the backend for it, and accordingly the function will be performed. So which is why we need the concept of JSON. So basically, think of like this front end when a front end sends data to a backend, or when any AP or when any API or something returns any response. Most of the time, data is in JSON format, so we need to learn this JSON handling very properly. And as you have seen, JSON looks very similar to a Python dictionary. So one thing is that handling JSONs looks very similar, so we can actually do it. So creating JSON is done. In dictionary, what additional thing you will do is you will define a thing like data equal to like this. But in JSON, no need to do like that. You can directly create it accordingly to the because you'll be creating separate files for it. So that's how a JSON is created. But they are not the same. Even though they look similar, they are not the same. Python dictionary is actually a Python object, but JSON is a string format which is used for communication. So that is very important. So for handling JSON, we need to import the JSON module first. So we will import JSON. Then after that, uh, there are few things which a few JSON methods that we need to know for handling JSONs. So first thing is JSON.dump. So JSON.dump is used to convert a Python object into JSON format and write it into a file. So let's say a Python object instance, we can take a dictionary. Suppose if I create a dictionary data equal to like say product. I will keep it like product is Lenovo, and then the price is like say 100,000, and then if it's available or not, you are passing your parameter whether it's available or not, then you are passing it as yes. So what you can do is you can you can like create a file. So you can create a file, you can write a file, you can update this data dictionary and create it like a product JSON. So what you can do is with open, just specify what file name do you need. want. So I'm giving it as product.json. So after I'm giving it the W mode, which means uh, write mode. Okay, basically you will overwrite the content. So I'm giving the write mode as if. So this is iterable which I'm giving. So I'm now what I'm doing is I'm doing the JSON dot dump function. What dump does it actually? Converts the Python object to JSON string. The Python object over here is what? Data. It's a dictionary. So I will pass data here, then pass F. Now there's another parameter called indent. Indent is like how much space you need between the JSON contents to look neat. So I'm just passing an indent say equal to 4. That's all. This will create a JSON file using the data object, data dictionary which is there. So let's try it. Yeah. So if you can see here, product.json has been created with the same data. So see the spacing indentation. So oh yeah, all. So this is how you create a JSON. So the other thing is JSON.load. If you want to read a JSON, let's say with open. Now you have already created product.json. So let me open product.json and then give it the R mode. So read mode and the same functionality as if. Then now what I can do is I can write a new data into it. So I can write new data equal to maybe say JSON.load f. Then what I'll do is I'll just print the new data and then I'll print the type of new data as well. Okay, so let's clear this terminal. Yeah, now we can run it. I'll just comment this. So it has printed what the JSON contains. It's a read mode. It has it has printed what the JSON contains, and then the class of the data is dictionary. So since it's the Python dictionary object which we are converted into a JSON, the class is dictionary. So this is how we can load and read a JSON file and uh, verify it. So the type is now a dictionary. If you notice it, that is basically thing which we want. And second thing, there is another function called JSON.dumps. So JSON.dump here we have created. What it does, it converts the Python object which is dictionary here to JSON. But JSON.dumps, this is another thing. What we want is we don't want to write into a file sometimes, specific file like product.json. I don't want to write it specifically into a file. What I do is I just want like a JSON string. So in that case the dump feature comes very handy. So I'll just do it. So I here have a data dictionary. Okay, so what I do is I create the variable JSON string equal to json.dumps. Then I put the data parameter, which is this dictionary object, and then I give the indent equal to just for some good looking formatting. Okay, so now I print the JSON string, and then I print the type of JSON string. Okay, yeah. So see, if you can see this JSON has been converted into a string object, and then the class has become string. So this is how you convert a JSON into a string object. This is actually used for when you want to play around with JSON files as a string for iteration, items, etc. So for those cases, it will be used this method. Then um, the other thing is, okay, let's maybe code a sample data and then sample file so that we will understand the use case more better. So suppose uh, I want to create a student database. Okay, so I'll just create it like students equal to, and then name this. I'm running out of name. What to give? Let's give Sham again, and then marks. Marks. Marks is maybe 80. Okay. Yeah. Yeah. So suppose I just create a thing. So I give here Priya, and I give here Ram. Marks is like different. So 34 and 46, 56 respectively. 34 is very less. Sorry. 78. Yeah. So what we can do is we can use the JSON.dump function first here. So with open. This with open is actually a good method because what it does, it actually it takes your file and then closes at the moment the function is done so that no data loss or anything happens. This with open method should be followed properly in when you're handling with company code base because all those are very vital, right? So yeah, just do data, sorry, W is write mode, right? First, we need to create a student JSON and by putting this structure into it. So we need to put W over here, not read. So we can give data equal to sorry JSON dot dump, and then we can give students, and then pass the iterable f, and then give indent equal to again 4. So I then import JSON. Yeah, import JSON. Yes. So once this is done, you can like create a new thing. So here, if you can see, students.json will be created. See how good the formatting and the everything is. Yeah. So it has created a JSON file. Now we can now if you want to read it, if you want to read the JSON with open, again you give students.json. Okay. So now we can give the R mode. Then we can give as if. Now what you can do is data equal to JSON dot load. This time it's load because you are loading the contents inside the JSON. Now what you can do is this data contains the object. This data actually contains JSON object, which is basically a dictionary. Now what do you uh, okay, so yeah, I do like this. You can just perform the iteration over the data. So you do it like this. Print wow. Wow is not printed because no marks is greater than 80. So suppose if I keep it above 50, I'll get 3 walks because 3 will have marks more than 50. Suppose if I keep more than 75, I'll be having 2 walks. So if I want to print who got the marks more than 75, if key of marks returns and way, print congrats. Again, we can use F strings here. See, lot of places F string can be used. Congrats. As more than 75 marks. Here we can add um, key of instead of marks you can add name. That's all. Name. That's all. If you do it like this, you will be getting the person who got more than 75 marks. Sham has got more than 75 marks. Priya has got more than 75 marks. So this is how you iterate over the objects, 5 objects basically. So you have created the data equal JSON.load, which that is from the JSON file you have created it as a Python object, basically a dictionary. Then same way how you loop through a dictionary, you can just do the functionalities. It is heavily used in backend systems. Like it might seem very layman and simple here over here, but in backend APIs, REST APIs, yeah, everything this JSON handling, this iteration is actually used. So we need to properly know the concept of this. It since JSON stores structured data, we need to read it and process it. So it's heavily used. So yeah, and then we will go to the file handling and OS module. This is the last part for this video. So yeah, now let's go to the file handling. So see, so far we have been working with variables stored in memory, but the real world programs don't just store data temporarily. They actually read from files. They write to files, they store logs, they load data sets, they do everything. So this is actually called file handling. So file handling allows your program to interact with external files. You might have seen this RW in the JSON thing which we did before. Yeah, the same thing basically. So for if you want to open a file, so let me create the sample text file first. Sample.txt file. Oh my god. Yeah. I guess some text file. So here, hi. Today is a very good day. Uh, Cricket is a very good game. Life is hard, bro. Yeah. So all these contents I create and keep. Now, uh, now here I give file equal to open sample.txt and then give it a read only permission. Basically, so just give file equal to open sample.txt. So the file is now in the root. So which means it can directly access using this relative path. So if you add it in any other folder, then you need to specify the proper path of it. So you can just get the path from here, copy path, relative path. So if it's in the root, relative path will work. Secondly, we use the open function to work with files. So open function has two parameters, the file name and the mode. We have many modes. Like as you can see here, R is for read, W is for write. If you use write, it will overwrite the content. And A is for appending the already existing content. And then X is for creating a new file. And then RB is for read binary, WB is for write binary. So RB and RW are like used for audio files, etc. Model for files, images, PDFs, etc. So all those are binary files. So you need those file handling to allocate them to their respective tasks. So the main important modes which you're going to see is RW and A. So if you open a file in write mode and the file already exists, it will erase the old content. So we need to be careful with it. I repeat it. So say if you open a file in write mode and the file before already exists, the previous content will get erased. So you need to be careful while opening in write mode. So the best practice is, as I said before, not to do like this. You do like this with open sample.txt, comma, the file mode as an iterable object f, data equal to f dot read. This is safe because the memory loss won't happen once the relevant function of this loop is done, or I mean this iterable is done. The file will close, so nothing to worry here. So if you don't close the files properly, it will cause memory issues. So this with statement handles everything safely. So if you want to write something to say, see the file now contains these contents, right? So if I want to write something, or if I use write, the content will overwrite. So the previous content will vanish. The content I'm having here is this. So the previous content will vanish. So say sample dot txt comma w no as f. Then I'm going to write f dot write hi Python and use the escape sequence just for a new line and f dot write um, you know this is file handling basically and again I'll give a slash n. Yeah, so this content will be overwritten. If I see this sample.txt, hi Python, this is file handling. So this content is overwritten. So this is how file handling works. If the suppose the sample.txt is not there, I'm deleting it. Okay, I'm deleting it. But I run this. Wait. I'm reading a file before even creating it. That's why it's causing error. I'll just remove this statement. Yeah. If I see sample.txt is created with the content. So yeah, this is how file handling will work. Now, if you want to read a file, there are few methods like f.read, read lines, and yeah, write and write lines are also there. So read is like reads an entire file. So you can read entire file. So read line reads one line of the file, and then read lines return a list of lines. So using any split which is there, it returns a list of lines, and then the write similarly just writes into the entire file. And for write lines, you can pass the lines which you want to write as a list. So using different list line elements, you can pass it. So these are the few elements which are there. So we can show it. So no issue with that. So we can like basically uh, wait. So I have written the file right. So now what I will do is I will do with open sample.txt and then I'll give it R mode and give it as F mode. So now what I'll do is I'll store the file contains a separate. So inside f.read, okay. So inside content I'll do the f.read. F.read reads the entire file. Now I'll give print content. Now let's see what is the output. Hi Python is for file handling. So the entire content is printed with along with a new line. Along with a new line it will get printed. If we keep it f.read line and let's check what is printing. So hi Python is getting printed. Only one line is getting printed. So after everything, you can see a new line is getting, new blank line is getting printed due to the slash in. So all these are very important things which we need to keep in mind. It can be useful as well in later things. So there's another thing called read lines as well. So you can also print the lines. So I'll just run it and show. Now the file is printed as a list, the entire lines. The file has printed a list. So inside everything you will be having slash n. Yeah. So that is why every time new line is getting printed. That is the reason. So these are the main file reading part. Now there's a thing called append mode. So inside the sample text, see, suppose I'll make it up a append, and then content. I'll write it like no if dot write this is a new file addition. Yeah. Now what I do is I again do with open sample dot txt comma no r again the same iterable f. Then what I do is no I give f dot uh, this time I give content equal to f dot read lines this time, and then I print the content at the end. Okay. Now this should actually give me this line new file addition without deleting the previous contents. If you can see, this is a new file addition. So this is how append works. It doesn't overwrite. It appends to the existing content. So all have been covered basically. Now we will go to the binary mode. Binary mode is also very important for AI. So binary mode is used for images, audio files, model files, etc. So now work in binary files. So binary mode is like used for images and audio files, right? So let's open a sample binary file which I actually downloaded a audio file here. So audio.mp3. We can just read the binary file. So for we can save with open audio.mp3 comma rb as if then data equal to f dot read print data. Now the binary data of the file will get printed. So if you see these are the binary data, so it will get printed over here. So it can read the binary data. You can do manipulations over it. You can pass this binary data into any other pipeline, AI pipeline, and then you can perform additions, perform operations on it basically. So by in binary mode the data is read as bytes, so basically try you can train this data, you can do anything with this. So this is how file handling works. So we have we learned the essential file handling for backend and AI projects. Now let's cover one small topic, OS module. So you must have seen this in many codes. So import OS. This is actually the OS module. So this module allows Python to interact with the operating system directly. So it helps you in assisting in creating folders, deleting the files, checking if the file is present or not, and working with paths. Basically, path handling is efficient with this. So if you want to, if you suppose these are the basic things, if you want to get the current working directory, you can do it like get cwd, you can get the current working directory. So see d/a grind is the current working directory, I'm getting it. And then if you want to list the directory, you can do it like list directory. Os.list directory will show the current files and folders in the directory, like basically this is one method. And then if you want to create a folder, say if you're working in some a backend project, if you want to create logs for it, what you can do is with this simple syntax you can create folder. So if not os.path dot exist, which means if the path logs I am going to create here, basically this logs folder, this path, basically if it doesn't exist in this directory, you just create a directory here, whole mk directory. So it creates a folder. Always you should check if the folder exists before creating, because if the folder already exists and if you create a new one without checking it, the folder will be overwritten, so every data will be lost. So you need to check properly. And you can also even make nested folders in, suppose inside logs, if you want to make logs for any specific backend, you can like make the respective I mean folder for it. So all those are high level, so that is not required in very detailed level, but you can like get to know. So os dot you can like maybe say log slash for if you want to say get the story log for Gemini, then you can just check it and you can just check if they exist. Okay. Yeah. So OS dot make directory logs. Inside logs you're giving a sub for directory which is Gemini for storing the Gemini logs, and then exist okay equal to true means you are checking if the current logs directory is present. So once if it is present, you can uh, create this true. Once if it's true, you can like create it. Else you can't. So basically it's like that. So make that actually creates a nested directories. So the main other thing which is very vital to be known is
the join path. So working with files, working with paths using OS module, you tend to join various file path. If you want to import a file path into another pipeline, you can't manually pass as strings and then give it. You need to join as paths so that the path is efficient, path is correct, and it can be properly migrated from one service to other. So what you'll do is you just create a variable, file path maybe, or then you do os.path dot join. Then what you can do, you can you can take the folder maybe logs, okay. Then inside logs you can take output.txt, okay. Now if you print the file path, see how it is, log slash output.txt, okay. So this is how the path. This is how the path you can join and then pass it to the um, file path for creation. If you want to create any file, if you want to create any directory, now okay. Now what we will do is we can do like this. Um, Same if you want to create a directory inside logs like output.txt. So what you can do, you can do it like uh, if you want to create any directory, so using this file path, what you can do is okay, let's do like this, file path equal to post.path.join, and then inside logs I want I want a directory named say logs for no audio pipeline, okay, audio dot txt, okay, audio, just keep the audio. Now what I am asking is, first I will check the file path how it is. File path is log slash audio, cool. Now what I want is, I want this path, if not os dot path dot exists, os dot mkdir logs. This is very important, like it's not like I'm keep on adding this actually is very important before you create any directory. If a log directory is already there, you should like not create on the top of it, so you should just update it. That's why we are confirming it. Once you confirm it, what I'll do is I'll make the directories here. Here I'll directly pass the path file path make, yeah, file path, and I'll check if exist, okay, equal to true. That's all. Now if you see in the logs, there's other thing called audio, the directory is created. So this is how you know create a file path and then create use the make the ARs directories to use this file path to create your directories. This is your os path dot join is like a very vital thing here. The other thing is, if you want to delete a file, you can do it like if os dot, again, if os dot path dot exists, maybe sample.txt. If it exists, you do os dot remove sample.txt to remove the file. So if you get the file will get